most of the crowd here. So today we're going to talk about something that's a little beyond connectors alone, which is our newer BF4 active optical modules. So this winds up being not only a connector, but a way to transmit optical data from one point to another. So we'll go through this, and then at the end talk about a couple of newer products that are coming from Hirose. Give me a second here. My screen seems to have locked up. Here we go. All right. So as I was mentioning, our BF4 connector is a optical active connector with a built-in electro to optical and then optical to electro converter to it. So it supports data rate transmission of up to 6.25 gigabits per second. It was originally designed as a way to transmit video signal inside of a system. So one of the first and most successful applications we've had has been in the medical industry, where they're transmitting data for what's coming across, so they can watch it on a monitor, so they can watch the operation on a monitor. So basically, you've got electrical information coming in, being converted to an optical data, transmitted over a fiber optic cable, and then converted back from an optical into an electrical signal. So some of the features of a BF4 or this type of system are we've got an easy to use E to O and O to E converter. It can travel very long distances, up to 100 meters, with excellent EMI resistance. In other words, there's no electrical magnetic interference. It's very small connectors, we'll see in a slide or two here, so it's really a space-saving device. It's very low profile, very low power consumption, and the optical cable is very flexible. You can see from the photograph there the size of it. We'll get into some dimensions in a minute, but the size of it there shows you, in relationship to a penny, what it looks like. So it is a unidirectional system, meaning that information can only travel one direction. So if you really need to, so in the case of a video monitor, as we were talking about, you really only need a unidirectional. But if you need a bidirectional, where you've got information flowing both ways, you would need to use two fiber optic cables and two sets of BF4 connectors and transmitters. So in this slide, you can see, I'm going to show you here, this is the driver, and this is the receiver part of it. So inside of here is actually the active components that make this system happen. And this is a separate connector. So basically, you solder the connector onto the printed circuit board, and then at a later date, you plug the receiver or the driver, the transmitter, into that connector. As you're putting it in, there's a clear tactile click. And then to remove it, there's a simple removal tool that comes with the connector. Huge advantage of this is that the connector can be soldered onto the board without the active components going through the wave solder process. So it can be reflow mounted just like any connector is, without concern for damaging the driver or the receiver. In fact, here on this next slide, we can see here's a high temp reflow profile. So you've got a maximum of 250 degrees C in that reflow profile, which is typical for a connector. It's designed with LCP materials, so it's designed for resistance in a high temp environment. Again, the BF4 is a connectorized electrical to optical and optical to electrical signal. So we've got a fiber optic cable, a very small fiber optic cable, glass cable that is. So some of the advantages of the BF4 system, in a conventional electrical internal connection, you've got low power consumption, small size, short distance wiring. In a conventional optical system, you've got high speed, noise resistance, and high-speed isolated transmission, but not some of the other factors. With the BF4, you've got all the advantages. You've got high speed, low noise, high-speed isolated transmission, low power consumption, very small size, and short distance wiring. You know, we always think of fiber optics as having the advantages of being able to travel very long distances. But if you're traveling a short distance, like a jumper from one board to another, a short distance can also be an issue with back reflection. But the BF4 system operates very well in that environment. So overcome some of the electrical challenges, very low noise, and very high speed in long distance transmission, as we mentioned, up to 100 meters. Also, very lightweight cable, lightweight and a very small, flexible cable. From a long-distance transmission, here's an eye diagram. So you can see in 3 different lengths here, at 2 meters, 20 meters, and 100 meters, we're all talking about a very large eye, which is describing a very good transmission in all 3 of those distances. From a noise perspective, on the upper left here, you can see this is what a BF4 interconnection would look like. So essentially, you've got a connector on 2 separate boards, and you can jumper them with a fiber optic cable. In a conventional microcoax, you've got, this would be about the size of the cable that would be required to jumper from one board to another. And on the bottom left and right, you can see the noise profile of that, or the effects of that. So in the optical noise profile on the bottom left, you can see it's extremely stable without any peaks at all. And on the bottom right, you've got some pretty substantial EMI interference profile on that. Fiber optic cable itself, this is old news, but just to review it, you can see the difference in size between the cable, the BF4 optical cable, and a typical Cat6 LAN cable. Significant difference in both size, weight, and flexibility. So again, some of the, just kind of reviewing again some of the differences. We've got a very small size, very low power consumption, and a highly flexible cable. From a power consumption standpoint, you can see here's the difference between a SFP connector and a BF4 connector. So we're going to be operating up to 6.25 gigabits per second, which is about what a conventional SFP runs at, only it's going to be a much lower power level. The power consumption is going to be down around 100 milliwatts, where SFP is closer to about 500. Some of the other products that transmit data, like an SFP Plus, XFP, Zenpack, are transmitted at a higher data rate. We're talking about 10 to 12 gigabits per second, but the power consumption is much higher as well. And we'll talk about in just a minute about some of the other things that Hiroshi is doing to address this data rate as well. So small size. Just from a height standpoint, you can see that the SFP is 11 millimeters tall. A BF4 module is 1.5 millimeters tall, very low profile. And the footprint, of course, is very small as well. We're only talking 11 millimeters by 5.5 millimeters for the connector. That's for the outside dimensions of the connector, and then the module actually lays inside of that. I want to point out one other little thing on this slide here that we haven't seen before is, can you see this little arrow here? That arrow in this direction indicates that that is the receiver. So there is a difference between the receiver and the transmitter. The transmitter would have the arrow on the other direction going the other way. So here's another slide showing the high-speed isolation of the signal. So with the optical connection, you can jumper from any point on this board to any point on the other board. You don't have to do it at the mating or the interconnect between those two boards. You can actually place this BF4 module any place on either of those boards. Very flexible for layout, and it handles up to 6¼ gigabits per second transmission, as we talked about before. For a conventional electrical connection on the right, there are chips that you would need to mount on the edge of each of the boards. To achieve 6 gigabits per second transmission, you'd need 150 Mbps. You'd need 40 of them to accomplish the same data rate transmission between the two boards. So the optical interconnection allows for a high-speed isolation of the signal transmissions and a very flexible layout. Again, just showing some of the differences between the chips if you're going to go board to board, as we were talking about. One thing to note here is this scale for the data rate, just to be able to put it all together, is an exponential scale. So you can see we're going from 1 megabit to 10 megabit to 100, all the way up to 10 gigabits. So it's really an exponential scale. If you were going to put it on a standard scale, these would be very small, the other ones, the capacitive isolator or magnetic isolator. So some examples of applications for this. We've got a very light with low noise resistance, capable of long transmission distances. So we've got test and measurement equipment, robotic equipment, factory automation cameras, medical equipment, basically anything that is going to be important to have that noise resistance isolation, lightweight type. So you can either go from a BF4, as we see here, to another BF4 on another board, or we can also go from a BF4 to a standard fiber optic LC or SC connector. So those are some options. For you as our sales organization, one of the big advantages of this is the average sell price. It's a high ASP. If it meets the application and they need this type of advantages that a BF4 produces, it's a nice sale for you. Hirose is doing a couple of other things. We're looking at the next generation of BF4, which is actually going to be a BF5, and we're talking about moving that up to 10 gigabits per second. It's not a product yet. You can't be out selling it, but there are other products that we're looking at are on the horizon that we will be offering in the future, not too distant future. The other effort that we're putting in this type of product that is in active optics, we're working on a cross-license between Samtec and Hirose. So Hirose is licensing the BF4 technology to Samtec, and Samtec is licensing something called their Firefly to Hirose. So they offer some similarities, but there are differences between the two products. The purpose for both of us is a second source supplier. So as you know, as many companies are designing in products, they really need to have two suppliers or they won't design it in. So they have two sources of supply. So that's an advantage for both Hirose and Samtec with cross-licensing these products. For Hiroshi, it'll also accelerate our BF4 sales through the Samtec channel, and vice versa. Samtec will be looking to accelerate their sales with our BF4. For Hiroshi, we'll be acquiring some technology where we'll be able to learn how to get to that 10 gigabit per second and higher as well. The Firefly, some of the differences between the Samtec Firefly and the Hiroshi BF4 are both the data rate and the number of channels. So if you remember, the BF4 is a single channel. The Samtec Firefly is a 12-channel, unidirectional as well, so it can only transmit in one direction, but a 12-channel signal. And the Hiroshi, the current BF4 operates at 6 gigabits per second, working on move up to 10 gigabits, where the Samtec Firefly runs at 28 gigabits per second. Obviously, it's going to be a more expensive system, but you might be looking at some of the same customers using the two systems. Samtec, the Firefly technology is going to be used more in the datacom environment, datacom storage environment. Some of the competitors to Firefly, Avago has two different products. One is called a mini pod, and the other is a micropod. They run at 10 gigabits per second, not 28 like Firefly does. And you can see the size of them. They're relatively good size connectors or systems. TE has something called a cool bit, runs at 28 gigabits per second. And then there's the Firefly at 28 gigabits per second. But you can see the size of the Firefly versus the cool bit, and certainly significantly smaller against the Avago products. So where are we at with Firefly? Well, we're currently developing the technology in Japan. We expect to be able to sample select customers in December of 2015, although it won't be a full product introduction yet. But if you've got somebody who you know is going to be interested in this, or you think will be interested in it, let me know, because we'll be doing some select sampling in December. And then we're looking at production and general market introduction in July of 2016. So less than a year from now, we'll be in the market with Firefly. So in conclusion, there's some pretty exciting new products that Hiroshi is developing for you to sell.